I'll just give it a few seconds for people to join before we start properly. Okay. Hello, everybody. Welcome to this webinar, wherever you are. The presentation today will be given by Steve Andrew of RVA. They're a leading global demolition and decommissioning consultancy with extensive experience in the process industries. The talk's been organised by the Good Practices and Process Safety Working Group of IMechE. My name is Richard Hallebrand. I'm a mechanical engineer. I've worked for around about 40 years on high hazard process plants, including managing decommissioning and demolition of process units and full plants. As well as introducing Steve, I'll be tracking your questions so that we can answer them at the end. If we don't get time to answer all your questions, I'm happy to carry on the conversation afterwards. And I've already put my email address in the chat for that. Hopefully you can see the slides. A little bit of housekeeping. The event will be recorded. It will be on YouTube in a week or two. We've disabled media for attendees, but to prevent disruption. If you're a registered delegate and you stop for most of the webinar, you'll automatically get a CPD certificate to your email address. Please put your questions in the Q&A or the chat. I'll keep track of both of those. Slides will be available afterwards as well as PDF, and again, that will follow on. If I spot any AI chatbots, I will immediately kick them out because if you can't be bothered to listen, then I'm not going to entertain your chatbots. Okay. So the Process Industries division of IMechE, what we do, we have industry focus in a number of sectors: bulk materials, food and drink, oil, gas, chemicals, pharma, upstream oil and gas, water and wastewater. And we are trying to organise specialised lectures, seminars and conferences and represent the industries on various government and international bodies, also promoting education, training and CPD as part of our learned institution. Most of us are volunteers with day jobs. But as a result, hopefully we've got some relevance to you. And there's QR codes on these. They are safe. I would normally never touch a QR code because it's cyber security. But there you go. These ones I promise are safe. We do have an equity, diversity and inclusion policy. Engineering is for everyone. So, no matter what your background, your culture, your sex, you are valued. We want your commitment and your help. So please, feel free to celebrate that diversity and get involved. Before I hand over to Steve, I've only got one slide for me. As far as I know, there's no international standard that covers decommissioning and demolition, which is sort of the subject of Steve's talk today. But there is a good, albeit slightly out of date, British standard. It's 168 pages long. I've used it. I think it's excellent. I've used it in other countries as well, even though some of the references are obviously British. If you don't have a subscription through your organisation, don't want to pay the money just to read it, if you're in a UK library, a lot of them allow read-only access. I live in Lancashire. It works for me. I just need my library card number and I can log in. I can look at any British standards. So if you're a top tip for any British people here, just check with your library or ask me afterwards. Right, at that point, I think it's time to hand over. I've already discussed me a little bit. I'll just hand over to Steve and maybe Steve can tell you a bit about himself and get started. So Steve, if you want to take the slides over, please.
Yeah, thanks, Richard. Good afternoon, everyone. Or good morning, even, depending on where you are in the world. Can you just confirm you can see my slides, Richard?
Yep, they're good.
Good. Just close that. Okay, today's presentation is around managing recovery for a major refinery. So this is me. I'm not going to go through this in a lot of detail, but I've got a lot of hands-on experience. Started as a demolition contractor, working on a lot of legacy sites, mainly on the old ICI type industries, and then became a consultant 23 years ago. And as part of that philosophy and part of RVA's DNA around driving improvements in the industry, we're great believers that by sharing our experiences, hopefully we'll stop other people having to have some of them. That's the good ones, of course. So a bit about RVA. We were formed in 1992. This is a picture of our site that we're a refinery that we're working on in Gulf. We're busy working on 4 refineries, desalination plants, power plants, pharma, and nuclear. So we work across all industries. So this is not about investigation. This is around how we recovered after the event. And I've been involved in quite a few of these in the past, and there tends to be some common themes and behaviours that tend to come out. Not all of it positive. And around managing people's expectations as well. Everyone thinks demolition, you turn up today, we all see the blowdowns on television of the power station coming down in 16 seconds. And there's a lot more to the process than that. And then obviously we'll talk through a real case study. And obviously we like to get it right first time, and hopefully you never have to go through this experience as an operator, but hopefully if you do, there'll be some learning that you can take away from this. So this was the event in the fuels area. Site services, emergency procedures came immediately. The fire was brought under control within a few hours. There was no injuries. But this is a good example where if you wanted a fire on your unit, it's not where this is. So under this pipe bridge, there's around between 100 and 130 plant and transfer lines. So it was quite an interesting project. So the first steps, the client contacted us. We were called out to see them, and we helped develop the roadmap through this. You can imagine there's a lot of pressure to deliver. So some of the challenges, this was slightly different to a lot of projects that we get involved in, where we're trying to take a plant and equipment from an unknown to a known condition, whether it's been decontaminated, washed, cleaned, or whatever. Where this one, we knew everything was full of hydrocarbon because of the potential unstable structure. We had no access, so decommissioning was very difficult. And certainly a positive was there was no asbestos. If this had been heavily contaminated with asbestos, it would have been a very difficult project. We had large items of plant and equipment. We had 3 columns, which again, what was structural integrity, distressed structures, potential stored energy. What was the effect of hydrocarbons being heated up significantly? And we were bound on all sides by operational units and plants, which I'll show a little bit more later in the presentation. So planning for any event, what's the worst thing that could happen, and what contingencies do you have in place? How do you isolate an area if there's a fire? And have you checked the valves in the system still actually work? We've been in situations in the past where we were looking to do boundary isolations and the valves had never been closed since the day the assets were installed. So, is that still there? How could you do a temporary shutdown, drain, degas, make the area safe? And does your critical equipment still operational? You can imagine with a fire like that, the control systems must have failed. So then, what's actually happening inside the columns, for example, and your tube bundles. And do you practice and do drills? What's part of your scenario planning? Have you had a fire in the middle of the block, and how would you handle that? And the important thing is getting the right team together. This is not just about process. You need to get senior manager and business line buy-in. There's a big commercial element here. You can imagine time is the driver, not the cost. But, this is not a blank check, so there needs to be governance in place. You've got your health and safety and environmental protection, and then you're touching on all the operations on the site, your operations, your engineering, your projects, your maintenance. And then there's the outside, like your public relations, dialogue with the external regulators who come in, and basically, they're in a position where a lot of the regulators we were involved in here had never been through this type of thing before. So again, we had to educate them and help them work through it. And then also your suppliers, getting your suppliers involved. And as we go through this, if we didn't have the camaraderie between the client, the contractor and ourselves, then this project would have been very, very difficult. So selecting the contractor, I've got a colleague on here who's probably got a different story to me around. We set off to visiting contractors, and it was a case of, are we going to Sicily today? Are we going to Madrid? So we had a round robin. We've seen about 5 or 6 different contractors who we'd had experience with in the past. And we were looking at HSE and corporate mindset around safety and working in hazardous environments, but there's lots of other things as well. Flexibility. Was the equipment ready? Can you get it to site in the next week or two? So lots of different things. And one of the key issues was around, could they speak English? Because you were bringing international contractors in, and you've got an international client, so potentially you had 3 different languages. So I'd just like to talk a little bit around how we would normally approach a project. So obviously, going from an unknown to a known position on a decommissioning demolition project, unknowns are a real risk and a hazard to us. So we go in, we do our insulation survey. We're not just talking about asbestos. We'd look at isolations. We'd look at how the plant's been decommissioned. We'd identify any low points, etc., etc. And all that is taking the site from an unknown to a known condition. And then you will go through your procurement process regularly in tandem, but there's obviously a tail end to this. So it's getting the right contractor, going through your pre-qualification, producing your tender documents, going through the tender process, and then basically your big clarifications, etc., before you appoint a contract. So normally on a typical project, I'm just going to chuck some timings out there. That could be somewhere between 3 to 6 months, depending on the information and things being available. So obviously on this type of project, we didn't have that time to be able to do that. And the other thing that always surprises me when you go into these situations, we need to recognise that people change. This morning I was thinking about where am I going for my holiday, and then we have an issue, and and then people go from that top of the behavioural triangle right down to the bottom, and then we start thinking around safety. Am I going to be able to pay my mortgage this month? Am I going to feed my children? And we need to be, we often miss that step, and it's all about people, getting people engaged and helping them calm down in some instances. And it's a bit like going through a loss. People go through the shock, the fear, and then you get anger and embarrassment and guilt. And then the blame game starts. And I remember being involved in the titanium fire when I was a contractor over nearly 40 years ago. And we had 11 fire engines on site. No one recognised it was a titanium fire, a metal fire. There've been some modifications that removed the original titanium one, put a stainless steel one in, and it didn't work. So they changed it and put the titanium one back in, but never changed the information. So again, back to, going to a known condition. Removed all the plugs out of the tubes, did all the air tests, and then we had a fire. And my line manager was asking me what I'd done. And there's like 11 fire engines there, and we're having an argument in the middle of this event. So again, the blame game needs to be taken away. Finger pointing, and then people's risk acceptance and perception changes as well. For some people, it goes down, and they become very nervous and don't want to do anything because they're worried about having another event. But other people, the acceptance goes up, and there's the pressure to correct. You get a can-do attitude, and it's okay getting the confidence back in the team, but that needs to be controlled. And then you get competing pressures. So you've got business drivers, time pressures. Do you know how much this is costing a day? And I never actually heard anyone say this, but we knew how much it was costing, and it was a 7-figure sum. The refinery was working at something like 40-60%. So you can understand that. And there was questions flying around, why isn't this finished this week? And all that needed to be controlled. And then on the other side, you've got the operational side who are focused on protecting the operating units and the health and safety and the environment of the people undertaking the work. And certainly I saw one of my roles in that was depressurizing that best you can. So, just keeping that under check, get a program, get a process, and follow the process. And the process might change every day, which I'll talk about as we go through. But it's important that you keep people calm. I never thought my boring nature would come in useful, but let's not go there. So starting the recovery, I remember sitting in a meeting and there was quite a few people in there, and it was quite emotional. And probably the first words I said was, hang on a minute, let's just put this in perspective. No one got hurt. And the worst thing that could happen now is we hurt somebody, we have an environmental release, or we have an impact on a neighbouring unit. Because if we do that, you will not hit your program. And if you have another fire, then the regulator is going to show a lot of interest, and that's going to stop everything. So let's focus on keeping people, the environment, and the assets safe. And it brought things down. The completion of the dismantling work, again, as part of the process, right, what's coming out all this? Well, do you need to keep anything for the investigation? Never thought about it. So again, looking at the investigation, getting to the root of what happened, why was the fire there, but why did that asset fail? And then also we recovered quite a lot of equipment that we got refurbished and then reinstalled back into the plant. Just keep an eye on the clock. No interruptions to live plant or utilities, and communicate, and keep communicating. People don't understand. You're bringing methods that people have not seen before. I remember sitting with the site director, and he said something. I said, if I'd come in August last year and said to you that we were going to use a high-reach machine and we were going to shear lines full of hydrocarbon, you probably would have took me away and locked me up and thrown me off the site. But that's what we're doing. So you need to move slowly and let everyone get on board and understand. And then, systems and procedures protect us here. I've been in loads of shutdowns. Well, it's a shutdown, yeah, but that doesn't mean to say we don't do it safe. And this is what the procedure says. And then there's also cultural sensitivities. So we had an Italian contractor and a Greek client, which they were both quite emotional. So whenever we talked around anything, it was a case of the Italians would go back and then they translate the people who didn't quite understand English, and the Greeks would do the same. And then we come back and say, right, okay, what have we agreed? And then the Italians or the Greeks would feed back, and they'd be like, no, that's not quite what we meant. And then we go through that process. And sometimes like our half-hour, 40-minute planning meeting for the next day or the afternoon's work, that would take 2 or 3 hours. But it was important to get people to the point of everybody understood what we were doing, what the hazards and risks were, and how we were going to mitigate and control those hazards and risks. So just to put things in perspective, this is where the plant was in the incident was in the middle of the plant. And when we brought our crane in, we had 120 centimeters clearance above 2 live water lines. That's how tight it was. The counterweight on the crane was actually above the water lines. And when we did any major lifting around the columns, for example, we got those isolated, shut down, and drained. And through the process, we plan to fail. So if we damage these lines, then what are we going to do? And we had everything in place. So to control it, we had a daily meeting at 7 o'clock in the UK, 9 o'clock, and then in the afternoon, and we talked about what did we learn yesterday? Are the systems and procedures that we've put in place, are they still relevant? We're working in a live operational plant. Do our systems still control? Is there anything that's going on that's changed since yesterday that's going to impact us? So it's not just about protecting the demolition and the live equipment, but can the live equipment, can that affect the demolition as well? And as I said, it was difficult. It had to be very patient. And we were incredibly lucky with the demolition contractor that we used, Despair. And to be fair, the operational team were probably the most cooperative I've ever worked with, because everyone really did have a common goal, and it worked. So obviously the electrical and control an instrument, we had a discussion around this, and I said, okay, what are we doing about this? Well, everything's burned through, so everything by default's isolated. Okay, so looking at a bit of risk management, can we honestly say there's not one 25-volt control cable in among that lot that's still live? Because the one thing that is guaranteed, when we start processing and cutting and draining into the lines, we are going to release hydrocarbon and vapor. And basically everyone was like, well, we're certain, but that's not 100%. Right, okay then, right, let's isolate the lines, let's isolate the cables, let's cut them between these two stanchions here, and then let's check, and then we've removed a potential source of ignition, so we removed another hazard and another risk. The photo on the right shows you where some of the isolations were. Some of them were probably more than 100 meters away, so we had quite a lot of product stored. So we were draining from both ends at one point. So emergency preparedness. So we were obviously working within a live plant. So we basically put Harris fencing around, and we had to allow access in some areas which we controlled on a daily basis. And around traffic management, we closed the road for the duration. And just putting things in perspective, the site on the left-hand side was producing somewhere around 4.5 tons of H2S an hour. So we were in a really interesting place. So we used a crane and the fly system, which I'll talk around, and an excavator to start with. Now, obviously, when the operators are working, the focus on what they're doing, and there's potential for them to move back. So we installed a laser system, a simple security system it was that we used, that you'll probably put to man your site, which protected the assets on the left-hand side of the slide and also at the bottom of the slide. And if the machine or the crane got within a meter, we had a meter exclusion zone, and then the laser. If the crane got within the laser zone, then the buzzer would go off in the machine and the crane, and we'd stop work. Obviously, there's still a serious risk of fire, so we had standby firemen in attendance. We had 3 process operators, again, keeping an eye on things. We installed vapor monitors around the perimeter of the site, both at ground and at height. And also we had Daleks, so mobile monitors as well, where we were moving around into areas. Oops, sorry. And then with the fire brigade on standby. What a good job that must have been. Sat there for 6 months watching us. And then the site process drain ran under the site, and it ran away from left to right. We did think about blocking that altogether, but what we decided to do was block it as it came onto the site, so we weren't getting any ingress from anywhere else. And that gave us an opportunity when we started draining lines, which you can imagine was very difficult, that anything that did spill would then go into the process drains and through the normal process and decontamination process. So obviously we had no access underneath, so we used a remote control block with a water jetting system, and hopefully the video will work. It's all done remotely. All done remotely. We had a remote control front loader as well. So we put the IBCs in. We captured as much as we could. We put neutralizing agents onto the ground, and then any other overspill then went back into there. But as you can see, it was a quite a messy project. But we had no physical access to this part of the site. And it was okay draining at both ends, but what you've got to remember, because there was a fire and the heat, all the lines sagged between the columns. So in between every set of columns, you had 100 plus low points. So we had to go through this process to basically remove as much as we could. The Despair came up with a really good idea around hot tapping. So basically use a normal hot tap, drain and pump out of the lines as much material as we possibly could, and then basically remove the hot tap, fill the line with foam, and then basically cut through the foam, and that gave us enough time to basically lift lines down that still had hydrocarbon in, but both ends were sealed, so we still had containment. The fly system, when we seen this, we were a bit like, okay, I'm not really sure how that's going to help us. But because of the access issues and the lack of space, it really did help us in with the fist cuts. There's just no room for an excavator. We had one excavator with holes or cut. The other one would either cut with a fly system or a hole. So again, really good process. And then we used a similar process with the columns. There was a separate access which they used to use as part of maintenance because of as part of the recovery of getting the plant up and running. That access was lost through putting the lines in, the transfer lines from the jetties into the rest of the refinery. So we didn't have that access. So we only had a very small area, and we basically this was a first for anyone. So we had quite a debate on this, and the only reason that that we approved the methodology because we had a 400% safety factor. We were fairly confident on the weights of the vessel, but again, we didn't know what the effect of the fire was, and we had really restricted access to go and do any investigation, so we just completely over-engineered everything. Water suppression was an interesting one. We had a 2-hour discussion around whether we should be using a mist or a fog or a jet. And basically, at one point, I said, well, is a fog or a mist the best idea? Because we can see the static that builds up in the cloud, for example. So we came up with the solution of a jet, and Despair modified a cement mixer to use as the medium for basically getting the water right onto the cut. So we've all seen demolition and projects where they're trying to control dust, and there's a guy or a girl or a lady stood with a fire hose trying to control it, and in reality all they're doing is making a mess. So this was critical, because even a shear, it's classed as a cold spark, and it's classed as cold work, but you do get a spark. Any cutting causes friction. So again, we were very conscious around controlling that. Identification, you got 130 lines. Once we started cutting, it was very difficult to identify them. And, we had site drawings, but 100% were they up to date. I normally say a has-built is a wish list by a designer, and what was done might not be the same as what's actually out there. So we were really lucky. We had a couple of process operators who've been there for 30, 40 years who knew the plant inside out. So again, as part of our planning, before our 4 o'clock meeting, they go up in the MUB, they are in the basket, and because I took the photograph, and we check which lines we were going to be working on, whether we needed to do anything else, because there was caustic in there, for example. We needed different PPE. So again, that good information. And the project in numbers, we delivered in 125 days, over 7,500 man hours on site, no incidents, no sim-ops, no injuries, no impact to live plants or equipment, and certainly no off-site complaints. So why did it work? Despite the business pressures, everyone bought into that the HSC was the number one consideration. And we had a can-do attitude, and we had senior managers in the meeting. I was there as a director. We had the operations, the area operations manager for the client was designated full-time to the project, and we had for every day we were on site, we had a director there from the contractor, so we could make decisions as we went through. Every day we went through what we'd learned today. Is our paperwork, our risk assessments and mitigations, are they robust enough for what we're going to be doing tomorrow? Do we need to do anything else? And there was no egos in there. The person who probably got the most stick was me, but that's my Greekish, which is Greek English accent, wasn't the best apparently. And communication was unhindered, and everybody worked hard. We worked 7 days a week, and we never let anyone work more than 6 days. And we changed shifts with a handover to stop people from getting tired, because it was high pressure work, and it was hot, and just protecting people, keeping everybody fresh. There was times I had to remind myself to go home, as you can imagine, because you get so ingrained in this. But if you don't stay sharp, then you get tired. Everyone gets tired. People start falling out, and that's when things go wrong. So again, success is no health and safety or environmental issues, no interruption. We started. It was completed ahead of program, including extra work. And we had a happy client, contractor, and RVA. So it was a win-win-win. And I don't know if I'm allowed to, but we were then appointed to support the health and safety and the coordination of the rebuild. Okay, so this is where we started, and this is where we handed it over to the projects team for the rehabilitation. Okay, any questions? Back to you, Richard.
Thanks, Steve. Very interesting. I might just add a few extra bits around that as well, because we've obviously concentrated on when you were given it as a project to do the job. But as a chemical operator, there's a few front-end steps, I think. And perhaps if I just share a couple of things with people. The first thing you need to consider is risks. Right now, Steve has rightly talked about health and safety risks, but there are other ones as well. So a risk register is a damn good idea, and you can cover things like, clearly that was a fire, but places make business decisions to close facilities as well, and that can involve people leaving, reputational damage, whatever it happens to be. And then decommissioning. I was on a plant 2019. It took us about 9 months to decommission it properly. And there's risks involved with those. And risk is typically probability times consequence times probability, if you like. So you need to sort of write these risks down, what could trigger them and what your contingency plans are. And then the demolition itself, well, there's a whole bunch of things. I got these out of the BS standard, uncontrolled collapse, health risks from the chemicals, fire, asbestos, working at height, falling into vessels, vehicle collisions, RTAs, electrocution, all sorts of things. So if you've never done a risk register, and you have to do this, it's very, very important up front, because you'll also get, for example, the finance or the HR people only think about their aspect. And you mentioned people, it's completely teamwork. And if you don't do it as teamwork, someone will get hurt. So that's the first point I'd just like to make. The second point I just shared, so going on into the decommissioning itself before you even get to demolition. Now, if you've had a fire, most of the chemicals have disappeared because they're burnt off. But if it's a chemical plant, that's not necessarily the case. So the way I did it, we got our team to decontaminate below the occupational exposure limits on the safety data sheet, because the risk of the demolition contractor is they're going to be exposed to something when they split something open, if they get close. And so I think it's a duty of the operator to clean the equipment properly, either themselves or using contractors or a combination. And what we did is we did that. For every piece of equipment, every pipe spool, we did a state of contamination certificate to say what had been done, how it had been cleaned, what state it had been left, and what residual hazards there were left. We also, I bought thousands of these stickers, put them on as we finished something, we put it on and we marked it on the P&ID so we know it was done. And then at the end, handed all that stuff to the demolition contractor, because then you could sleep at night knowing that you've not left any unknown chemical risks. And the final point is just, I did mention the BSI guide, the British Standards code. There is another one as well that Steve rightly mentioned. I should have put on my slide, but I didn't. Energy Institute also does one, and I think it's available as a free download. When we issue the slides, I'll probably put 2 or 3 extra slides in to cover these points, just so you've got them, but they'll be in the recording. Okay, so while I've been doing that, we have been getting some questions as well.
In reality, this was like a small photograph in time of what actually was going on. So we could run a full session on how we remove one of the columns, and the business risk assessment. I can imagine for the rest of the process was huge, because you can imagine now,
particularly with a running business as well, and trying not to shut it down.
You've lost quite a bit of your capability, but you still need other raw materials and refined materials for the rest of your equipment. So then you're out there buying them on the open market, and I'm sure everyone selling was behaving themselves. So there's a lot here, and the things you said around your decontamination, the risks around that, and designing for demolition and going from an unknown to a known state. That's stuff that we do as part of bread and butter, working with the client. Yep.
But and I think, and the good thing, I mean, it's clear from some of the videos, is that nowadays you shouldn't be at the equipment you're demolishing, you should be standing off. And
Yeah.
there's absolutely no reason for people to get up close and personal with hot work and with working at height and vehicles. You can have an exclusion zone, you've got high, long reach equipment that can do it safely. So
We never.
providing I think the client cleans it or gets it cleaned properly and it's planned well, that happens. And the other thing of aspect of that, of course, is nowadays as well, certainly in the UK, we're required to recycle a huge amount of that. And it's all possible, even down to the concrete can be crushed up and used as hardcore.
Yeah.
Right.
Sorry, go on.
And I've got a question from Andy Fisher. Thanks. Hi, Andy. How was the damaged equipment assessed to decide if it could be reused or scrapped, particularly the piping?
Very little of the piping was recycled. It was past past that condition. The basic mainly took pumps and tube bundles, and that was it really. And then they were taken away, and then the investigations was carried out. So we removed all the pumps, all the condensers and everything else. They all went away, and somebody else looked at that. And
Okay.
quite a lot of it came back. Stuff got refurbished, etc.
Okay, so I guess it's down to how much heat damage it had as to as whether it is trustworthy or not.
Yeah.
Amos Salademi, how did the recovery strategy balance environmental remediation with restoring operational capacity?
It's a good question. So we looked at the environmental side. We controlled any discharges. Any discharges we either captured in the IBCs. Anything that didn't go in the IBCs then went into absorbent material, and then under there we were quite lucky that the site process drain ran under the area, and that was bunded, and we didn't have any discharge issues or any spikes on the discharge as we went through, and a lot of the fume we monitored, and we never had any hits on the fume, and we were using the water, etc.
Okay.
So
a question from me. Other than just going straight to RVA Group, how do people know who are the cowboys? How do they approach the right people? Because
I'm not sure we're going
you
to
wouldn't go
RVA.
single tender. Most people will not go single tender straight to RVA. You would go to a bunch of people. So how can they get some comfort? Like a bit like checker trade, that you're going to people who are competent.
Well, I think Richard Branson said that yeah, we can do it. What's the question? And that you meet very few contractors who will actually admit that they can't do something. So then you're looking at experience, real projects, not just fancy brochures. Shows you projects. You want to be looking for projects that they've completed that look similar to your project, for example. And every project's different. So,
Yes.
I worked on 1,000 petrol stations, and every one was different. So every project's the first time. But if it's a refinery and they've worked on a refinery, they understand how to work in a refinery. And then looking at people as well. How much experience have they got of actually doing demolition, not just being an operator who's decided to go into demolition because they've moved from there. And look, people's references. Talk to clients. If they can't give you clients to talk to, then you've got to ask yourself why.
And then also another follow-up question with that. I think I know the answer, but perhaps you can tell me, is can anybody just decide to demolish sections of their plant, or do they need to get permission and permits to do that?
I'm sure you know the answer to that, Richard.
I do, but I'm not sure everybody else does.
Yeah,
So.
you need to get permits, and in a lot of areas you need to go through planning. In the UK, you go through planning and get a Section 80, 81. In Scotland, for example, you'd need a demolition warrant. For this job, we needed to get a permit from the regulator. So again, it's down to local. a site we're working on in the Middle East, again, we need to get signed off by the regulator. So you can't just go in and decide to demolish your plant.
That's the correct answer. Yeah.
Thank you.
Ibiza Karoma, and I don't think it has been covered. Was an MOC completed for this project, a management of change? And how long did it take to get the MOC to the right status? Did this impact the project start date?
We'd never seen the MOC, but we were told it was in place. So,
I will add my own comments on that. So on the plants I've been involved in decommissioning, we've generated a huge number of MOCs because, for example, if you're decommissioning, you remove the chemicals, suddenly, and you've turned the equipment off, suddenly the noise areas are not noise areas, or they don't, and suddenly EX areas, hazardous area zones, are reducing. So we do an MOC to cover that. If people are leaving, organizational MOC, because you need to manage safely what you've got left. And as you wind down, there's a whole, you might have some novel techniques that you want to do to decommission or to replumb something through the decommissioning to keep maybe the wastewater treatment going. And when the power's off, you might generators, steam, all sorts of things. So I would say there's two levels of MOC. There's an organizational MOC, clearly, with stages on it. And I think there's also a bunch of other traditional technical MOCs. And they do impact the start date, I can assure you, because having been there and done that bit, until you've got everything agreed, and certainly in the UK, we would then have to approach the Health and Safety Executive and the Environment Agency to get their permission to carry on.
Certainly, we get involved in a lot of MOCs. When you go into this process, it's probably the biggest change management process you'll ever be involved in on a decommissioning project. You're going to be losing key people. How are you going to manage that? You're going to be decontaminating and isolating different to what you did before. So standard practice now might be you go in, you cut a cable, you isolate it, you tie it all back, you earth it, and then you cap it, and then you tag it.
Yes.
Well, you might not do that on demolition. So again, you're looking at dispensations within.
Yeah, I mean, on that, we went all the way back to the main substation, and that's what we were doing. We were chopping right back at the main sub and having some small generators for the small supplies you need. None of that. We haven't covered that in this. If people are keen for follow-ups, let us know. You've got the you'll get the feedback form shortly.
Okay,
just keeping with the questions. Sorry, Steve. Just keeping with the questions. I was just going to
mention that someone flicked up about CDM. Yeah, CDM's important. I deliberately haven't mentioned CDM because I know there's international people on here, and I didn't really want to make it UK orientated. But again, certainly in the UK and Northern Ireland and Southern Ireland, there's a similar process. You're looking at your CDM principal designer, planning supervisor, pre-construction phase. And again, you need to validate them that they actually got the skills, knowledge, and experience. It's not about competence anymore. Have they got the experience? And I think it was Einstein said, isn't it? True knowledge is experience. So anyone can get a certificate and pass an exam. But
I would highly recommend, as has been said by other people, by Ibiza, do the MOC. And if you do the MOC, do the risk register to go with it, and then throughout the process, the big you have a master MOC if you like. Just keep track of it. CDM, for people who don't know, is Construction Design and Management Regulations in the UK. It's an acronym. So Adam Blankiron, I think, did you use the people change theory triangle you mentioned at the start throughout the project? It looks like a good way to frame the situation, say it how it is, and take them on the recovery journey. The culture must have been difficult to manage.
It was easy. It's an awful thing to say, but at times it was managing people's frustration because of the language barriers. But the Greeks couldn't speak Italian, the Italians couldn't speak Greek, so English was the common language. And how I and RVA and my colleagues who were involved in this, how we like to do this is we push it into one team, and we build up camaraderie around the project, so people like get into that. And there was an example where we had quite a debate around electrical isolations. You can imagine the control and the electrical team were like, how are we going to get this ready in the timescale? Yeah. And oh, we haven't got resources, we haven't got this, we haven't got that. So we were in a position then where we were helping them with their line managers around, if you want this to happen, then this is what they need. And it was just, and then talking through. So, for example, demolition just looks wrong anyway, doesn't it? Imagine telling someone, like I said to the site director, you're going to bring a 30-meter machine in, you're going to shear a pipe, and you're going to let it fall to the floor. So again, it's just taking people through the process. And like I mentioned, let them understand.
You know, for example, most of us are pretty ignorant of what machinery is available, but you can shear through big stanchions, columns, steelwork in a second, which would take an hour in hot work, and you don't have to have the person there with flammables working at height, possibility of falling off. It can just be done so much quicker nowadays.
So what we do is basically we spend an hour or two doing some like demolition awareness. These are the methodologies that we're going to be bringing. These are the hazards and risks that we're going to manage, and that's why we need the isolations. This is why we need the water. This is why we need you to block off drains and monitor what you're doing so it doesn't affect us and we don't affect you. So it's, and then, you know, do it with a smile on your face. Just bring people down, get them involved in the process. Everyone has a word. No, there's no bad questions. And it's just building up that trust. And I remember to the minute almost that it was very stressful and it was really difficult, like getting everyone aligned and going through that process again and again. Sometimes it took us a couple of hours to get agreement, but we kept pushing through. And then as soon as we did the first cut and we moved the first stairway, the culture and the attitude changed completely. So, you know, it's given people time to understand what you're doing.
Martin Ralph, sorry to just move you on. Martin Ralph asked a question, but I think this was in Greece, but he said he asked if there's a start delay due to accident inquiry. Did the authorities get involved?
We never got involved in any of that. We never got involved in any of that.
Okay. Harry Moss, what guidance do RVA offer for handling waste, e.g. specialist contractors or on-site clean-up, disposal, etc.?
We would go through our normal pre-qualification process, and depending on what the waste was, advise accordingly.
Okay. I think that's been a good range of questions. Again, if you've got follow-up and you want to talk to Steve or me, my email address is in the chat. Just follow up. I will just go on and last few slides to close the webinar now. So this isn't the only webinar we do. There's an awful lot of them in IMechE, and certainly the process industry division, we're typically doing 15 to 20 webinars per year. You can see some of the recent ones here. And there's again, that's the URL and the QR code if you want to go to that. Our next one is really interesting coming up. It's in about a week's time. The climate's changed. How can engineers adapt? So you think climate changes in the future, but we've already got extremes of temperature, weather events, etc. now. And it's not just about Greenpeace and COP meetings. We engineers have to react. We have to change our designs. Our assumptions are based on what was prevalent when plants were built 20, 30 years ago, and they're wrong. So this will be a great discussion. It's the first of many webinars that IMechE and IChemE are doing together, and the first one will be the Environment Agency will be leading it. So please even if you can't attend in person, register for it. We've also got another one. This tends to be more traditional process industry, circular economy. They talk about that, and again, we've got several of that about that, but that's coming up a week later. And you subscribe to the YouTube channel, you'll get notification about these. But better still, go onto LinkedIn to the mechanical IMechE process industry division. If you want to feedback, well, there's a QR code. You can give us some feedback about how useful or otherwise this was. If you want to suggest other topics, whatever you want, it's not a problem. We are volunteers, but we like, if you've got something that you want to share around, most of what I do for this is safety related, right? It's not commercial. Engineers don't automatically get some of this stuff in their graduate training programs or their degrees. This is the new way we do CPD, I think. And I think at that point, I'll just leave that up. I don't know whether, Steve, you got anything final to add? Because otherwise I'll start to close it.
That was really like a whistle tour through that project. There's a lot of elements around that weren't touched. We only had 30 minutes, 35 minutes. So, if anyone's got any questions, my emails and contact details and the RVA website are on the last slide. And obviously you can find me on LinkedIn if need be. But no, thank you. And I hope you really found it useful.
Yeah, and I think, Steve, I'm hoping it raised more questions than answers, if that makes sense, because safety is about knowing what you don't know. And once we know that, then we can start towards competence. So thanks for sharing that. It's a great example. And thanks for some high quality questions to everybody. I'll now close the event, but again, you can follow up later if you want to. So thanks, everybody. And see you again soon on the next one.
Enjoy the rest of your day. Thank you.